Okay, here we go. Welcome to lesson 11.1. We're starting a new chapter, chapter 11. Very, very geometry uh, type of chapter. I know it's the class is geometry, but this is kind of your classic using formulas to help find area of both any polygons and circles, using finding lengths in polygons and circles, surface area, volume. So it's got that feel to it of probably what you thought of when you originally thought geometry, as far as three-dimensional shapes and figures, stuff like that. So today specifically, 11.1, like I said, circumference. We'll stick with circles coming off of chapter 10. Circumference and arc length. So there's a formula we'll look at for circumference. We'll find the lengths of arcs, and then yeah, that's pretty much it. We'll look at a couple situational things, but I think all very doable concept. So here we go. No time to lose. Let's jump in and get it going. So circumference. First off, just making sure we're on the same page with what is circumference. You can almost think of it as the perimeter of a circle. You know, the classic would be to snip the circle, lay it down flat or on a straight line and measure how long it is. That's what we would call circumference. So the distance around a circle is what we should think of when we think of circumference. We're seeing here kind of two, I guess, different formulas. Both involve pi, this idea of pi. One is set up in terms of diameter. So knowing diameter, I would just multiply that times pi, and that would tell us what the circumference of the circle is. If I know the radius, we would have to double the radius. So that's where the 2 comes from. Twice the radius times pi would also tell us circumference. Okay, so I know this is probably I think this is the first time this year we're looking at pi being involved here. It's just a constant that's there in circles. It's all circles that if you're kind of like, where does this come from, or why are we talking pi? I don't want to spend forever here, but if you were just to solve this equation for pi, just think about it for a second. C divided by D equals pi. That's actually kind of where that number comes from. The circumference of a circle divided by its diameter. We would see that that number approaches pi. So definitely a circle concept when we start talking about pi, this 3.14 number. It's just something that exists in circles, and we use it to help us find circumference. All right, let's take a look. So starting kind of simple. A couple things, though. Pause, try, as always. Solution is right here. We're being asked to find the indicated measure, write our answers as a decimal. So pi is always going to involve, if pi is going to factor in that's an irrational number. It continues without end or repeat. So we're going to have to round our answers to the nearest hundredth. There's also, though, a component of exact answer. So we got to talk a little bit about what does that mean. I guess long story short would be you're going to leave the symbol pi as part of your solution. Okay, so let's actually start with that for our exact answer to start, because we're going to use the exact to help us find the rounded. So I'm going to use my formula, circumference equals 2 pi r. Right, that's just our generic formula. And if I substitute in what I know, the 2 is a constant, the pi is a constant. The only thing that we really need to use this formula is the radius, which it flat out says, hey, your radius is 11. Great, let's do it. So my exact answer is right here. I would just do we can multiply out of order. 2 times 11, which is 22. So 22 pi meters would be our exact answer. Notice that is not rounded. 22 pi meters is our what we would call the exact answer. For the rounded, so if we kind of break this here and just do the rounded, you don't really need much more information. It's just a matter of using a calculator with the pi function to say, hey, what is 22 times pi? Because obviously, if we're going to buy material or we need to build something that has this circumference, 22 pi is all well and good, but it'd be nice to kind of know, like, hey, so when this is all said and done, this is about 69.12 meters. So yeah, I mean, obviously, if I'm walking into a hardware store and say, hey, give me about 70 meters of rope or whatever we're building or making or whatever, that's a little more meaningful. So exact versus rounded. Okay, using the formula in just basically a different approach here. Let's still start with the exact. So now we're being asked to use the formula C equals 2 pi r to find the radius. Okay, so now it's different in the sense that I guess I'll work here to start. I know the circumference is 18, and we're solving the equation for r. Okay, so I guess this one's more of a kind of a top-down, traditional get r by itself type of situation. So I would look to divide both sides by 2. Okay, so now I'd be sitting on 9 equals pi r. And if I divide just mathematically by pi to get rid of it on the right side, we'll just come up here. I don't want to keep scrolling down. Here's my exact answer actually. 9 over pi, let's see, yards is our radius. Okay, so there's your exact answer. Now again, just like we talked about before, that doesn't mean a whole lot in the sense of what does that mean? The radius of the circle is about how big. It'd be kind of nice to know. So there's our exact answer. I'd still like to do that because there are certain situations where it's kind of nice to stay exact, where I might be now taking this radius times something else or doing something else with it. So I'd like to keep it as exact in certain situations, but for the sake of the problem, we just need to now, using my calculator, do 9 divided by pi and get a radius of about, if I round to the nearest hundredth, 2 places, 2.86 yards. All right. So there's just a couple different ways of looking at using that relatively simple formula, either finding the radius or using the radius to help us find a circumference. All right. Well, that takes care of the circumference formula. Use the formula for circumference. Good. The next part, arc length. So let's talk here. What is an arc? We know that from chapter 10 that an arc is kind of just like a snippet, a piece of the circle. So if I were to cut out just this little piece from A to B and say, hey, well, how long is that? Again, straightening it out and using a ruler to measure, is what we would call arc length. We've talked about arc measure, so don't get confused with measure versus length. Measure was in degrees, right? The full circle has a measure of 360 degrees. This arc measure would be the same as this central angle right here. But those are in degrees. We're talking length. I want to know actually how long it is in inches and centimeters and meters. Okay? We'll actually focus right here. I don't know if we need a whole lot with this one. So it's all proportional. If we're reading through this as I'm kind of talking there, the ratios are equal. I always kind of think of it as part to whole. So if I look here, the whole circle measures 360 degrees, right? We just said that a second ago. The whole way around, the whole length of the entire circle is 2 pi r, aka the circumference. So the denominators are totals in measures and in length. And then the top parts are the parts of it, of each respective way to measure an arc. So we got our arc measure in degrees, and our arc length, again, in like a linear unit. So they hold that same, think of it maybe as a percentage. Here's maybe a real simple example. So let's say on a circle, I know I've got an arc that measures 90 degrees, right? There's my right angle. This is a 90-degree arc out here. What portion of the circle's circumference is that red arc making up? Well, 90 degrees is 1/4 of 360. So this red arc length would be 1/4 of the entire circle's circumference. So hopefully that makes sense. What we're going to basically do is kind of use this as like almost like a fill in the blank type of proportion. And it'll take some of the guesswork out about, should I multiply, divide by 2 pi? What do I do here to solve it? So make sure we add this to our notes. We'll use that over the next couple problems here, okay? So here we go. Let's do it. Find each indicated measure. Round your answers to the nearest hundredth when necessary. I think there's a couple that might come out a little bit cleaner than others. So this first one, can we do it? Well, we'll leave them all up here because I don't know how much I'm going to write. But if I write small enough, I think we can kind of squeeze it in. So we're looking for arc length. So what I would do, I'm going to use that proportion that we just saw on the last page, and just, let's see, kind of, I usually start with this one because this is a constant. The circle never changes, whether it's humongous, tiny. The measure is always 360. And then I guess it kind of depends. But if we're looking for the length of arc AB, I'm going to put the measure of arc AB with the measure of the circle. So see if you follow me here. The measure of this arc AB is 60 degrees because that's what the central angle is right there. Okay. So we're basically kind of saying this makes up 60 of 360ths of the circle, or 1/6 actually. This is making up 1/6 of the circle. So you could also think about it as, well, if I know the circumference, this arc AB length is making 1/6 of the total circumference. We'll do it more like this, where what did we say with this lower left was reserved for here? The circumference, 2 pi r. So if I know my radius is 8, a lot of times I'll just plug that in there as 16 pi. Now, if you're like, wait, hold on, Mr. Crow, where'd that come from? All I did was plug in 8 in our circumference formula for my radius and say, hey, that's 8 times 2 is 16. So of this proportion, I know everything except my kind of upper left, which we just looked at, that's reserved for arc length. All right, so it's a little more systematic. Like I said, there's definitely intuitive ways to go about it. We were kind of talking about the 1/6 and stuff like that. You can do that as long as I can follow what you're doing. I'm okay with that. But I like this here because we've done so much with proportions this second semester that if I take my cross multiply here, 360 times x, I don't need a calculator. And then actually, if I go this way, 60, let's see, clear my calculator, 60 times 16 is 960. And I'm actually just going to leave the pi in there. There's kind of one of the advantages to it. It's just kind of nice to stay exact for right now. And say, all right, well, what do I got to do to finish this? I guess I just got to divide by 360 degrees, because that's how you, whoops, that's a 6, 360 degrees. That's how I would get that x all by itself. So the length, not the measure, we know the measure is 60 degrees. The length of segment, not segment, of arc AB is, let's see, I got to grab the calculator. I'm going to type 960 times pi and divide that by, just making sure I can read my own writing here, 360 degrees. That little snippet of arc right there is, didn't say it around, did it say it? Nearest hundredth? Yep, so we'll say about 8.38 centimeters. So relatively painless, I would say, as far as using that that almost template for the proportion when it comes to arc length. Right. Okay, let's look at part B. Different circle, different whole information, everything like that. I know the pictures kind of look the same, but let's see. Find the circumference of circle Z. That's all we need is the total circumference. We can do that. All I need is the radius. Ah, shoot, they're not giving us the radius. So I can't just go into my formula for 2 pi r. Darn it. But if we take a look at that proportion, what do we say always was kind of these bottom numbers? The total measure of a circle and the total distance around a circle, which we call circumference. So it's kind of preset up for this lower left-hand portion of my proportion to use as the circumference, right? We stuck C down here before. Let's do it again. Okay. What else do I know? Do I know the measure? I need obviously more information, right? So I know a measure of this arc XY. So the measure of arc XY based on this figure is 40 degrees. And I know actually this 4.19 is the length of the arc. So we're still using the proportion, just kind of in a different way. Now this one I love because I know pi is not really involved here. If I cross multiply this way, 40 times c is 40c. I like that. 360, let's grab the calculator. 360 times 4.19. I'm getting 1508.4. And then we'll divide both sides by 40 to get C. I don't think is exactly what? 37.71. Whoops, that's another 7. 37.71 inches all the way around the circle. Okay. And again, there's different things you can do as far as this 40 and these 360. I know some people had said, hey, Mr. Crow, this is 1/9. So like this 4.19 makes up 1/9 of the entire circumference. Like all they were doing was kind of reducing. They saw that, hey, 4 and 36, those are kind of multiples of each other. This is 1/9. Can't I just take 9 times this 4.19? And ultimately, that's kind of what we did in more of a, like I said, more of a systematic way. But that's absolutely true. All right. So if you're like, well, yeah, Mr. Crow's saying this weird stuff like after each problem, don't get hung up on that. I think if you stick with the proportion and being able to understand that, I'm not saying I want you to be robotic about it. I mean, I like that we're able to kind of understand and see some of the situation, but the proportion template should be okay for us. All right, a third time. So now we're going to use that proportion one more time to figure out the measure. Remember how this notation means the measure of arc RS, which is going to be in degrees. So let's take a look. What do I know? Always I know that the full measure is 360. Do I know the circumference for this particular problem? Not exactly, but I do know the radius. Right? It's pointing at this little segment RT right here. This isn't a diameter, unfortunately. But it's telling me that the radius is 15.28 meters. So if I go to my formula right here and plug in 15.28 times 2, we're getting 30.56 pi for a circumference. Okay, so there's still a component where I'm going to have to use this circumference formula. So 2 times pi times r gave me 30.56. And then what do I know? I know like this portion right here, this length from R to S, arc RS, is 44 meters. Okay, so you again use the units to kind of guide you. What are going to be the units on this unknown value up here, degrees, because we were looking for measures. So degrees go with degrees, length units go with length units. I could probably put a little meters here, but it'll be a little cluttered. Okay, cool. So hopefully you understand the setup there. It's just a matter at this point of cross multiplying and solving it. So I'm going to stick with the x, kind of going this way first. So 30.56 pi x equals 300. Go this way now. 360 times 44. I'm getting 15,840. Okay. Now, if we take care of our calculations and we understand how this goes on the calculator, I can divide kind of at the same time by 30.56 pi all at once if I want, because ultimately that's how we're going to get rid of everything on this side. Just be careful here. Check your order. I'll do it verbally. I know you can't see my calculator, but I'm going to take that 15,840. I usually just do it in 2 steps. So 15,840. I push divided by 30.56. Push equals though, and then now push divided by pi as like a second, almost like a second entry on your calculator. All right, so I'm getting for an arc measure, take a step back. Once it seems like, wow, that seems so big. It's 164.99. If I round, it says 9878, so that would round me up to 99. Does that seem like reasonable? Is that accurate? And I would say 100%. Why? We kind of not debated, but we kind of flirted with the idea that this could potentially be a diameter, which would make, if this were a diameter, what would my measure here be? Exactly 180 degrees. So we're close to a semicircle, but not quite there. And look at my number. I think my number reflects that. That's 164 point, almost 165 degree arc, which is pretty darn close to a semicircle. So I think my answer is legit. It at least kind of matches up with my picture, and I think we're okay. All right, look at all that work. Wow. Too much brown, though. I should have used some red or some green. All right. Oh, well. All right. The last thing we got to look at. So if we're just kind of checking off boxes here, use the arc measures to find arc lengths. Did it. Okay. We even found some arc measures. We found some circumferences. The last thing we got to do is that real life kind of situational stuff. So I like it here as far as what's going on. It's fairly applicable. We've got a car tire, truck tire, whatever. To the nearest foot, how far does this tire travel when it makes 15 revolutions? So basically, what we're saying is, all right, this spot on the ground right here, I'm going to roll my tire forward. How much distance does this cover if I roll it exactly 15 times? So that blue line, or not line, but that blue mark that I made all the way around there, hopefully we see that and say, oh, that's just a circle. That's the circumference of this tire. Now we have two ways to find circumference. We've got circumference equals 2 pi r, and then we had that proportion that had circumference down here, arc length, arc measure, and then 360. The problem with the proportion here, I know we're coming off 3 problems, so it's like everybody, it seemed like in class everybody wanted to use this. The problem is we don't have any arc lengths or arc measures on this one. So there's just not enough information to use this. And if I was going to fill in circumference, I might as well just answer the question, basically. So I think we're going to use the formula. This is actually the perfect time to refresh and look at that alternate formula we had, pi times d, pi times diameter. Because if I look here, these red numbers kind of line up with, let's see, from top of the tire to the bottom, we're getting all the measurements, 5.5, 15, and 5.5 again. Indirectly, that's saying, hey, guess what? This circle has a diameter of 26. If I add those up, 5 plus 5 is 10, 11, 26. Yeah. So our diameter ends up being 26. So as an exact answer, this has a circumference of 26 pi. So one revolution, let's actually multiply that out just so we can kind of put a real number to it. 26, are we following there? I'm using the pi times diameter formula. So 26 times pi, I'm getting 81.68 on my calculator. That's my circumference, inches. Now, I'm not done. I got to be careful that I don't just circle my answer and say, sweet, that was so easy. Although I mean, that was very doable. I would say, well, it was asking about 15 revolutions. So this number that we just came up with, I like it. We're going to use it. But I need to multiply that by 15. So times 15. Now we're getting better, I think. So 15 revolutions of this particular tire with a diameter of 26 inches travels 1,225.221. Again, I haven't cleared my calculator. I've been just had this on my calculator. I just pushed times 15. What makes this one? This is maybe more the tricky part of this one. Let's put my units on there. That's 1,225.22 inches. And what was it asking about? To the nearest foot. So that maybe is a little mean right there. So if that's the correct number in inches, we just say, all right, well, I need to divide this by 12, right? There's 12 inches in a foot. So if I take 1225.221, I haven't cleared it, divided by 12, we're getting about, here is my final answer, 102.1, and it was to the nearest foot, so about 102 feet. Here's what I would put in my answer blank. And maybe you see, like, that would definitely be, like, that's probably the most relatable unit there. 1,225 inches is great. That's kind of hard to visualize. 102 feet, I at least have a chance to maybe visualize that in my head. Like, hey, we're on a football field. It's about a third of the length of a football field if I spun this tire 15 times. So stuff like that is where we might want to have it like that. Okay? So there's a somewhat real-life situational, at least, connecting it to a situation instead of just saying, here's some numbers. Last one. Look at that. Fourth example. We're doing all right time-wise. Let's read. I didn't do a great job of reading that last one. The curves at the ends of the track are shown are 180-degree arcs. So the curved part, 180-degree arcs. The radius of the arc for a runner on the red path shown is 36.8. So I guess I've got that information from here. The center of my circle, of this kind of imaginary circle, because it told us the 180-degree arcs of a circle, is 36.8. About how far does this runner travel to go once around the track, round to the nearest tenth of a meter? Okay, so first off, I guess with this 44.02, this is for a different question. There was a follow-up question here that I took off, so I don't want to confuse anybody, and maybe you already are confused. Let's get this 44.02 out of here. That's the follow-up question was, okay, well, how far does a person run on the blue track, which we could definitely figure out, but just for the sake of this problem, we're just looking at the red person on the red path. Okay, so that's the first thing. What are we looking at here? Like, what do we got to figure out? Well, if I kind of cut out the straightaways from here to here, so like this distance right here and this distance right here, whether you're red or blue, I guess it doesn't matter. Those are both 84.39 meters. So if I'm kind of just game planning this, so my total distance, right, to the nearest tenth of a foot, or tenth of a meter, sorry, I've got two of those straightaways that are 84.39 meters. Okay, like that'll factor in later at the end. The last part we have to kind of figure out is, well, great, how long is this piece right here? And how long is this piece right here? That's kind of the hang up, right? And I've got two of them. Let's see if I can do this. I did it. It worked well when I tried it the other day. If I pull out, there we go, that piece right there, that piece right there, and put them together, oh my goodness, maybe the coolest thing I've ever done. As well as this piece right here. Can we do it? That's pretty good, which we know is 36. So we got to kind of write that in there, I guess. 36, it's going to be too small. My fingers are too fat. 36.8 meters. What do we got to find? What do we have to add to this 2 times 84.39 meters? Basically, the two end pieces, two semicircles, put them together, you get a full circle, right? So I need to know, what is the circumference of this circle? Well, I've got a formula for that. 2 pi times 36.8. Our circumference, if I just, for right now, kind of stay exact, 36.8 times 2 is 73.6 pi meters. Okay, and that, just don't miss that accounts for both this and this. So we've hit it all. Our 84.39 we're accounting for right here. We've got just the circumference of one full circle, because those are my ends. So I really just need to add 73. Just don't forget the pi. I'll even do that sometimes where I forget that the pi was part of it. Yeah, so let's do it. Let's get all those numbers crunched. The total distance that a person on the red track is running, or the red inner lane, I guess, is running 70. So I've got the 73.6 still on my calculator. I'm going to go times pi. Going to give me a decimal number, 231.222, plus 2 times 84.39, because we've got the two straightaways. Calculator's coming back at me with 400.00 meters. Wow, like we're spot on there. To the nearest tenth of a meter, well, it's to the nearest hundredth, it's still 400. So about 400 meters. I know it's around to the nearest hundredth, but it was so exact, which actually, believe it or not, is your typical kind of one lap, what most people would say is one lap around a traditional track. So anyways, that's neither here nor there. 400 meters. All right, so kind of a composite one there as far as, just looking at hitting the straightaways and just kind of understanding what do we actually got to find here. Instead of cutting a circle in half, we just put the two halves together and made a full circle, and got it done. So that's it. Wow, not a terrible lesson as far as length and concept. So we've solved real life problems involving circumference and arc length. Perfect. Nothing else to cross off. We got it done. So there's your notes for lesson 11.1 on circumference and arc length. We're definitely done. We'll call it there, and I will see you in future lessons.